Today we are going to review the first 35 pages of a PhD thesis titled Efficiency in the Columbia Database Query Optimizer. Query optimization is an area where database systems can achieve significant performance gains. Modern database applications demand optimizers with high extensibility and efficiency. Although more than one decade's effort have been contributed to these areas, the state of the art in the optimizer research is still not adequate for the demands of business. The goal of Columbia project is to provide efficient and extensible tools for query optimization, particularly for complex queries and new data models. Efficiency is the main focus of this thesis. This thesis describes the design and implementation of the Columbia Query Optimizer, which obtains significant performance improvement while extensibility is not sacrificed. Based on the top-down optimization algorithm of the Cascade Optimizer framework, Columbia simplifies the design of the top-down optimizers by carefully re-engineering the search space structure and search algorithms. Two pruning techniques are implemented which can achieve significantly better performance improvement. Usability is also improved in Columbia by adding a friendly user interface and extensive tracing support. Let's look at the results and experimentation. First, the performance of the Columbia optimizer on chain and star queries is illustrated, including expression generator, memory usage, and optimization time. Second, the Columbia optimizer is compared with the Cascade optimizer. Third, the effectiveness of the global epsilon pruning technique in Columbia is examined. The queries used in the experiments are join-only queries. Two kinds of queries are examined, namely chain queries and star queries. They represent two basic shapes of the join orderings. In a chain query, all joint relations are connected side by side through their joint predicates. In a star query, the joint relation at the center is connected to the surrounding relations through their predicates. Coming to the contributions, this thesis has described the design and implementation of the Columbia Query Optimizer. Performance improvement was demonstrated by comparing with its predecessor, the Cascades Optimizer. The performance of the Columbia Optimizer shows that it could become practical for optimizing large queries. The ability of optimizing large queries efficiently is greatly demanded by many modern database applications. Now let's talk PS score. Just to be clear, the PS score is just for the first 35 pages of this 104 pages long thesis. So overall this thesis is a decent read. At least the first 35 pages, so it gets 9 out of 10 on readability. With 114 pages long, it scores 8 out of 10 on length. Its PhD thesis with pretty good description, so that makes it 9 out of 10. Its industry value and learning meter is high, so it gets 8 out of 10 on each. Overall PS score is 8 out of 10.